Hello and welcome to Lesson 9. In Lesson 8, we spoke about the relevance of writing a chemical equation, of balancing that chemical equation. And here in Lesson 9, we will see how to apply the balanced equation along with the other information that we've been learning about, moles and mass and 1 mole of a gas from previous lessons to solve this simple stoichiometric problem, which says 60.05 grams of pure charcoal burns completely in an excess of air. And that means it really burns by reacting with oxygen, completely reacting with oxygen to produce carbon dioxide. Predict the volume of carbon dioxide produced at standard ambient temperature and pressure. So recall this, that 1 mole of any gas at SATP occupies 24 liters or 24.00 dm cubed. That of course is given to you, and it applies to all gases under these conditions. Then we should recall that to convert moles to mass and mass to moles, we could use this little relationship here, where the mass in grams is equal to the number of moles multiplied by the relative molecular mass or the relative atomic mass. And if you wanted to get the number of moles, you divide the mass given in grams by the relative atomic mass or the molar mass. Looking at the question, we see 60.05 grams of carbon. The first thing we need to do is to convert those 60.05 grams of carbon into moles of carbon. And we go to the periodic table and we see that the relative atomic mass of carbon is 12.01. That is 12.01 grams per mole, making up a mole. 12.01 grams, making up 1 mole. And we are going to divide 60.05 grams by 12.01 grams per mole. Multiplying here by the reciprocal, 12.0 grams becomes the denominator and 1 mole becomes the numerator. And then grams cancels with grams. 60.05 divided by 12.01, that comes to 5. 5 multiplied by 1, you get 5.000 moles. Notice I've put 3 zeros here, and that is because I'm keeping this answer to 4 significant figures, because the data provided here was 4 significant figures, and the data for the relative atomic mass of carbon is given as 4 significant figures. So therefore my answer then could also go to 4 significant figures. 5 moles of carbon is actually consumed in this reaction. What we are saying essentially is that 5 moles of carbon burns in 5 moles of oxygen, and that produces 5 moles of carbon dioxide. We are able to conclude this because the mole ratio from the balanced equation says 1, 1, 1. So if we actually have 5 moles, it means it's going to be 5, 5, 5. So to predict the volume of carbon dioxide produced at SATP, it means we then need to take this 5 and multiply it by the volume of 1 mole at SATP. And that would be 5 multiplied by 24.00. And that would give us an answer of 120.0 dm cubed. Notice that I've put my answer to 4 significant figures with the right unit, dm cubed. So these were the steps that I followed. This was one relationship that I needed to draw upon. I needed to balance my equation, and I needed to have this bit of information here. Now I would like you to go to the worksheet and solve some similar problems on your own.